So I want to begin by saying the last presentation is actually very complimentary to some of what I'm doing, but hopefully you'll see that connection as I move forward with the next 15 minutes. So, hi, my name's Alex. I'm a PhD student at the University of Waterloo, and today I'm presenting Mercury, Empowering Programmers' Mobile Work Practices with Microproductivity, and this was work done during my second internship at Microsoft Research. So when we think about programming and where it takes place, we normally think about devices that look like this, right? The laptop, a desktop with a few monitors, and then a desktop with many more monitors, right? Anyway, programming is relatively stationary as a work practice, and it relies on personalized development environments that are made up of a variety of different build tools that really poorly translate to the mobile context, right? And I feel like this room is probably I feel like I'm preaching to the choir in some sense here, but the question that I asked, or that we asked in this study, was how can we empower programmers with mobility in their work? And the way that we went about this in terms of our study was across three different stages. And the first stage was first conducting a contextual inquiry in which we observed programmers in their workspace, an online survey that was inspired by their findings in our contextual inquiry, and the goal here was to determine whether or not our findings from our inquiry generalized at scale. And then finally, we ended up building a system named Mercury. And Mercury is a mobile programming tool that explores a microproductivity-based solution for mobility. So just to highlight some related work, there's three big pillars of research that we build on top of and extend. The first of which is mobile programming. And mobile programming is a broad space, especially if you consider information work broadly in the mobile context. But we looked at studies of multi-device use, as well as cross-device programming, and systems like Touch developed from MSR's earlier days, roughly a decade ago, as well as Maria Husband's work that has kind of inspired things like Apple's Sidecar, if you're familiar with that. Similarly, because mobility inherently involves pausing work, we also looked at the literature on interruptions as well as task resumption, focusing specifically on interrupted programming tasks, namely the work from Chris Parnan and Thomas Latoza. And finally, this is no surprise, we also looked into microproductivity and microtasking, but I should point out the obvious reason we did this. So our work is heavily integrated into the space of interruptions, and there's been substantial work that shows that microtasking is actually highly resilient to interruptions, as well as it's a really convenient way to design for limited attention scenarios, which in some sense the mobile context is all about. So just to give an overview of our study, there's technically three phases, and I've divided the third one into a fourth, which is our real evaluation component. But let's dive into the contextual inquiry first. So our entire study was really motivated from the get-go by one simple research question, and that was how do programmers utilize their mobile device while mobile? So to answer this question, we again went into programmers' workspaces and observed them for an hour. And during this hour, we posited two different scenarios. One was a planned interruption that they knew about beforehand, and then an unplanned interruption that happened. And during both of these contexts or scenarios, we looked at how they used their phone. This was more or less an interview process that we recorded and then analyzed and transcribed, or transcribed and analyzed. And just to highlight our findings, the major takeaway, if you're going to take away anything from our inquiry, is we effectively designed or found a taxonomy of mobile programming tasks that people perform, and the tasks themselves range from anything related to capturing thoughts on the go, all the way up to actually engaging in full-blown programming. So based on the taxonomy that we saw in our online survey, we then wanted to determine whether or not our findings really generalized at scale. So what we did is we took this taxonomy and then asked people whether or not they practice these tasks currently, as well as want to practice them and are currently incapable of doing so. In addition, we also wanted to understand the challenges of pausing work, specifically focusing on the question of whether or not resumption itself is still a challenge, because this problem itself of resumption has been studied for upward of 20 or 30 years now. So just to highlight some findings, on the right you'll see a plot that actually shows all of the responses that we had for the taxonomy of tasks that people could either currently perform or desire to perform, but currently feel they can't. So the existing practices that we found, which were capturing thoughts, using email as some sort of information transfer network between devices, and then conducting online research, for example, finding web resources on Stack Overflow or MDN, for example. All of these things are generally related to transferring and seeking out information, and they're exploratory in nature. Now, if you look at some of the things that people wanted to be able to do, they were generally grounded in augmenting existing information or artifacts. And this included primarily, at least in terms of popularity, bug triage, and code review. So when we asked people to really get at, or to get at resumption, whether or not it's still a challenge, we actually asked people to reflect on the last programming task that they paused, whether it be in the last week, the last 2 weeks, et cetera, and we asked them how long it would take to get back into the task mentally. And what you're looking at is a plot that effectively shows that the resumption estimates, the longer someone's been away from something, obviously increase and it becomes more challenging or time-consuming to get back into the task. But the major takeaway here is even for recently paused tasks, 80% of the people said that it would take upward of 5 to 10 minutes just to get back into something. Okay, so having now said that, I want to talk about Mercury as a system and effectively how we used our findings from our contextual inquiry and our survey to design the system. So Mercury is a mobile programming tool, and it's built on principles of microproductivity. And it's built on really two principles altogether from the ground up, and that is function-oriented microtasks and a ready anytime task queue that you can effectively engage with as soon as you pick up your phone and leave your workspace. So to bring our idea to life, we integrated Mercury into Visual Studio Code, and the way it works is upon going mobile, what Mercury will do is it will perform a real-time scan of the user's workspace to extract functions with source code, without source code, and then repeat the process for any other file that's in the workspace. And from these extracted functions, we generate microtasks. And you can generate one or more microtasks. There's not necessarily a limit for a particular function. So just to give you an idea about what the task interface itself looks like. So you're looking at what people see on the phone. And on the top left-hand corner of the interface, you'll see the function name that the microtask has been generated from. You see the function's content or its context. You'll also see the file name in the top right-hand corner. You'll see the task panel on the center right. And then in the bottom left, you'll see the Git branch that the task is being pulled from. So Mercury supports two different types of microtasks, the first of which is grounded microtasks. And grounded microtasks are inspired by principles of function design and testing, and the general premise here is we're automatically generating unit tests for people to find use cases that execute terribly or poorly, right? So in some sense, people are effectively reviewing a recommended use case for this function call, and the way it works is it parses the argument's presence and then generates the unit tests for that particular function. Now, for anything that actually fails in terms of a unit test, what will happen is, unfortunately, it's a little bit blurry here. You can't really see it, but on the right or on the left, you've got effectively the code before someone goes mobile, and on the after side, when someone's completed a task while someone's been away, Mercury will automatically generate a source-level edit in the user's code while they've been gone, so they effectively can see this edit as soon as they get back to their workspace. And just to be clear about what's actually included in this edit, it's added to the docstring, and it includes the actual function call and an optional note that the user can specify as well why the execution failed. So alongside grounded microtasks, there's also exploratory microtasks, and they're inspired by principles of information seeking. So in some sense, this is actually resonant of Michael's presentation just now. But the general idea here is that we take the function docstring and actually use it as a query to Bing. And from the results from Bing, we turn each result into a suggested recommendation. So the premise here is people are reviewing stuff on the go for an implementation that doesn't exist yet. In other words, a function body that's empty. And just to be clear about what shows up here, unfortunately it's blurry again, but what's being injected after the fact is the actual name of the web resource. For example, this could be the name of a Stack Overflow article, as well as the URL from which it comes. So that's Mercury in general, and I can talk about some more technical details if time permits, but let's talk about how we evaluated it. So we conducted a controlled lab study, a first use study, inspired by best practices for evaluating both resumption tools and software engineering tools. And it started with a 30-minute phase in which we invited participants into our study workspace to begin the task. We sent them away with a phone that had Mercury pre-installed. And then we invited them back into the workspace after their 30-minute period or phase 2 had completed. And then within the next 24 hours, we scheduled a 20-minute exit interview over Skype. So just to be clear about the task, we needed something to actually give people. given that it's a controlled lab study. And we resorted to a lot of what prior literature has used, which is classic arcade games. And we took the concept of Tetris, built it out ourselves, and basically made it a bit more fun and engaging. So what we did is we added portals to Tetris. In other words, if there's a piece falling through the green portal on the right, it should come out on the left. So it adds a bit of a unique challenge, but the premise here was we intentionally broke and left 4 functions in the code base unimplemented. And the task for our participants was to effectively implement these functions. So Mercury can be configured to, again, create as many microtasks for each function as we want. And we specifically targeted these 4 functions, configuring Mercury to create 5 tasks for each of the functions, totaling up to 20 microtasks in total. So just to get at what we measured during this study. So again, we had a pre-study questionnaire where we collected demographic information as well as re-administered the same mobile work practices scale that we used in our survey. In terms of during study metrics, we had recording and log data that included the workstation recordings that were recorded with TechSmith Camtasia, and we also had event logs from Mercury as well as Visual Studio Code. And finally, we administered a post-study questionnaire which included the system usability scale, a reattachment scale that's generally used in occupational health psychology to better understand how well people are mentally reattaching with their work. And we also used the PANIS-inspired scale to get at whether or not people's perceptions of themselves were actually positive in terms of productivity, relaxation, and engagement with their work. So just to give a quick overview of recruitment, we randomly sampled a company-wide email list, and the only criteria for effectively inviting people into our study was that you have to be a programmer and you have to have a year's worth of JavaScript experience. In total, we recruited 20 full-time programmers, 18 of which were male, 2 were female. All were software engineers, 2 of which were interns, and 70% of our participants were between the ages of 25 and 44. So there's a bunch of information I can go through with our results. I do want to go ahead and clarify that because of limited time, I'm going to breeze through this a bit quick. But in general, Mercury was positively received. 85% of our 20 participants wanted to bring Mercury into their programming workflow as is. Only 2 people voiced complaints about the device itself. As one person said, it was nice because I felt like Mercury was intuitively looking for things I would have looked for anyway. It also reported, it also received good/excellent usability scales on average. One of the most common threads through all of the interviews that we had in our exit interview was that there was a universal appreciation for being able to continue work while on the go, as well as continue or transfer information across devices. And getting information between the devices is usually the problem. Mercury kind of helps this by handling the synchronization for you. Now to get at the participant's perspective and impact, Mercury instilled feelings of productivity, engagement, and relaxation. And this was mostly universally said across all of our participants. There was only 2 or 3 participants that actually said relatively negative things about the system, and we'll get to them in a minute. But a part of how relaxed I felt came with knowing that I no longer needed to be in a particular place to be productive. Now to quickly highlight the strengths and shortcomings of the microtasks, grounded microtasks were generally reviewed or perceived as an opportunity to not only fix, but also observe and see. So simply being able to read the code that someone had just written was a huge thing for them, but being able to actually take action on fixing it was even better. It was also noted that grounded microtasks obviously introduced test cases that people didn't think about or consider, which isn't totally surprising because we didn't tell people up front that we were wanting them to, say, build unit tests or write them. In terms of exploratory microtasks, there was an opportunity to gain a new perspective, is really how people viewed them. It reframed the problem for me, as participant 15 said, and there's also an element of surprise that comes with completing them, because you had no idea what was coming next. Now, it's not all rainbows and sunshine. There was a challenge with both microtasks or criticisms for both microtasks in that they weren't necessarily always relevant and sometimes they became repetitive. But it should be noted that several participants had very positive things to say about anything more accurate, as participant 4 says, would win us the Nobel Prize. And to really quickly highlight when Mercury would be used, the usage scenarios were broad, but generally touched on moments of downtime. And these range from commutes to brief breaks, and we even had one person say that he would rather use Mercury instead of play Temple Run while on the toilet. So there's a really meaningful use case that wasn't reported in the paper, but you and anyone watching online, again, gets to hear about. And finally, in terms of our findings, resumption was a really big theme for several people, but not everyone. As participant 9 said, Mercury kept things available. In practice, Mercury would help bring down the ramp-up time when I get back to my workstation, and I can just go and code right away. And this was supported by a reattachment questionnaire that we administered in our post-study questionnaire. And so much of the comments about resumption and its positivity were voiced about knowing what people would do as soon as they get back. So just to wrap up really quickly, Mercury is kind of a first step toward a new frontier of on-the-go programming. As participant 4 said, with Mercury, I'm not tethered to the desk as much as I would be, and I can still accomplish meaningful work. And again, we see Mercury as the first step toward a new design of systems that actually help people be productive while away. And similar to Michael's comments about the notion of collaboration, we also, I won't necessarily say ignored, but we're cautiously aware that we were supporting the individual and not something that was necessarily practical, right? Now, the ability to pull in reviewers and use canned comments and add voice commentary, how they code, et cetera, participants saw the practicality of the system in practice, and they regarded the social aspect of something new. And there is a bigger story behind this. Some of this happened accidentally in one of my earlier pilots, but maybe I'll get to that later. And finally, as a final comment, I do want to say that, in succeeding and empowering people in their mobility, it comes or has the potential to come at a cost. And any work in this space in the future should absolutely respect downtime. Just to keep it brief, I'm out of time, and I'm happy to take questions, though.
Hello, Soya Park at MIT. I have a question. Thanks for the amazing talk. I think from the tool, as user do microtasks, it looks like it's added as a comment in the code base. Mm-hmm. And I just wonder the design rationale behind that. So people like that the comment because in the code base it's right there, or would people don't like it as it's cluttered, or I just wonder why you added it.
It's a great question. So I can tell you one of the limitations that I didn't mention up here is we assume that people document their code. Right, that's a design decision that made sense to us, and I think there's an entire study waiting somewhere for someone to take about understanding how people document code, how you can motivate people to document code, and whether or not this is really as possibly intrusive in terms of documentation practices. Right. So the short answer is that probably matters, but we didn't touch on it.
Cool. All right, thanks. Awesome talk. I think we all know that people don't document code, but I think you're getting at something really interesting, that the stuff that people want to do on the go might be the things that people never have time for, like email, documenting code, bug fixes, review. I'm wondering if you sort of just vaguely ask people, what do you want to do? But have you examined this from sort of a software engineering process point of view of what actually makes sense for people to be organizing their microtasks around?
In short, that's part of the reason why we did our formative studies. And admittedly, the formative studies were trying to get at what do people currently do, as opposed to what are they, what are all the opportunities for software engineering, right? So it was kind of a first step. Admittedly, there's tons of things, documentation being one of them. The opportunities are there. There's a follow-up study, ... somewhere, if someone wants to take that over.
Thank you again, Alex.